Hello, students. So today I'm going to be doing a quick video on how to solve a two-step equation. Okay, so when I say a two-step equation, what I mean is there are really two key things we need to do in order to find the value of our unknown, which we call our variable. Okay, so in this equation, I have 1 equals 3x plus 4. Well, I know what 1 is. I know that 3 is the coefficient of the variable x, and I know I've got this plus 4 here, okay? But what I'm trying to find is the value of that x. What is that x equal to? What value of x would make it true that mat A, this one, equals 3x plus 4? Remember, that's the whole point of the solution to an equation. It tells us what is the value of the unknown such that both sides are equal. Okay, so the very first thing I'm going to do is I'm going to start by writing out my equation. And it doesn't matter whether you start by writing it here on your justification step area, or if you start writing it or building it, I should say, on the tiles mat. Either way works. So I'm just going to write 1, and you always want to write that equals 3x plus 4. Okay, let me try to make that a little neater. And that would be my given equation. I'm just going to write given though. Okay, so now what I need to do is I need to build my expressions, or excuse me, my equation. Since there's the equal sign, it's now an equation. So remember, an expression would be something like this 1 or this 3x plus 4. It's a mathematical sequence or a mathematical sentence you could think of, but it doesn't have the equal sign. So an equation has the equal sign, an expression does not. So I've got 1 on mat A, and on mat B, I need 1, 2, 3 x's, and then I need this plus 1, 2, 3, 4. Okay. Now, right here, I've got our justification word bank. And if I'm not sure what to do, I could look here and think, I don't see any parentheses, so I don't need to do that. There are no terms on mat B to combine. Okay, I got a 3x and a 4. I can't combine them because they don't have the same variable. And there's only a 1 here, okay, so I can't combine that with anything else. And remember, we can't combine terms on other sides of the equation, okay? We can only combine like terms on the same side. So I'm mostly looking then at additive inverse and multiplicative inverse. Usually, believe it or not, I like to follow this order here. Okay, I like to do additive inverse first and multiplicative inverse first. You're not wrong if you do it in this order, or if you don't do it in this order. You could do multiplicative inverse first, but then you'd get fractions and it'd be all weird. Additive inverse is usually easier to do than multiplicative inverse. A common mistake I see people do is they will do the additive inverse on mat A. And that doesn't help us. What I'm trying to do is I'm trying to get rid of the constant on mat B because that's the side with the variable. Whichever side has the variable, that's the constant I'm trying to eliminate. Okay? So in that case, I don't want to add a -1 or subtract 1 from both sides. That would get me 0 equals 3x plus 3, but I'd still have a constant on mat B. So instead, what I'm going to do is I'm going to try to get rid of this plus 4. I'm going to add the opposite. So remember, additive inverse means that you are adding the opposite to both sides so that you can remove this term, the plus 4. So the opposite of a positive is a negative. So I'm going to add -4 to mat B, except if I'm going to add -4 to mat B, I need to keep things equal. I need to add 4, or excuse me, I need to add negative 4 to mat A as well. So negative 1, negative 2, negative 3, and negative 4. I'll move it over here. Okay. So now I have made my 0 pairs. Okay. So I'm going to go ahead and let's move this. Okay, look at that. I've made 4 0 pairs on mat B. And now all my unit tiles are gone. So all I have to worry about now are my 3 X tiles. And similarly, I'm going to make a 0 pair on mat A, but I still have some unit terms over here. So now I need to show my work algebraically. So what I did is I added negative 4 or subtracted 4 on both sides. And that made a 0 pair. Okay, and my justification is additive inverse. Okay, for short, you can just write AI because this is, I don't want to have to make you write a ton here. However, if you were typing this, then I would definitely want you to write additive inverse, okay? Or if you were handwriting this, I definitely want you to write additive inverse. For the purpose of this, I don't want to, try and make you cram, additive inverse in a small space, so don't worry about it. So now I need to simplify. I've already simplified my tiles. That's what the 0 pairs do, but I need to simplify my algebraic expression. Well, 1 minus 4, there's 2 ways I could figure that out. One, I could just do 1 minus 4, and that gets me negative 3. But look here. I have a positive 1 and 4 negatives. That's the same as 1 minus 4. And I'm left with negative 1, negative 2, negative 3. I'm left with a negative 3. Okay, now I'm at B. I know this has to equal 0. The whole point of doing additive inverse is so that this equals 0 so I can ignore it. Because 3x plus 0 is the same as 3x. Okay, so that makes my life a lot easier. Okay, so now what I need to do is I need to try and find the value of just x. I'm actually going to move this down here so I can make a little bit more room for myself. Well, I have 3 x's on mat B, and I want to know the value of just 1 x. So what I'm going to do is I'm going to use the multiplicative inverse. And what that allows me to do is it allows me to make 3 equal groups on mat A and mat B. That's 1 equal group, 2 equal groups, 3 equal groups. Now, the big thing to remember is your groups have to be equal, because what we're really doing is we are dividing by the coefficient. Okay, so you can see here, when I'm making those 3 equal groups, what I'm doing is I'm saying 3x, I'm going to split that into 3 equal groups of 1x each. And that's the exact same thing as division. When I do that, I make my giant 1. And I just realized I'm using the wrong color. I'm using green when I should be using yellow-orange. So let me fix that, sorry. So I just made a giant 1 right there. Now, because this is an equation, I need to treat all sides equally. And that's the negative 3 divided by 3. Now, because this is a giant 1, I know that on map B, this is going to simplify to either 1x or, remember, we don't usually say 1 apple, we say an apple. Similarly with math, you don't have to say 1x, you can just say x. So I'm going to get rid of that 1. But now here, I need to algebraically figure out what my solution is. Negative 3 divided by 3. Okay? Now, again, there are two ways I could use the calculator. I could do negative 3 divided by 3, and that gives me negative 1. But I could also look here at my groups, my 3 equal groups, and see that on map B, I have x. Well, that's what I have here. And on map A, I have negative 1, which is the same answer I got when I algebraically did negative 3 divided by 3, or negative 3 split into 3 equal groups. So whether you're looking at the tiles for your answer or whether you're using a calculator, you should get them both right. Okay. Now, I did forget one last thing. Oh, nope, not red. There we go. I forgot to write our justification. Again, you can just write MI for multiplicative inverse here. But again, if you're typing or writing, please do write multiplicative inverse so that way you actually remember what MI stands for. And then lastly, negative 1 equals x. Well, that is our solution. That is our solution. Okay, so we found that negative 1 equals x. I hope this video was helpful. I'm really hoping that this helps jog your memory, not only about what we went over in class, but about what you learned last year, if you were able to get to equations. Have a wonderful rest of your day, and I will see you later. Please feel free to reach out with any questions.